that it would be simply illogical to just go on and move on before discussing the topic of pipelining. So first of all, let's consider what's the topic of pipelining. See, I personally feel right from my childhood that for every concept you need two definitions. A technical definition and a layman's definition. Well, I feel that first it would be better to make you understand the concept of pipelining in layman's definition. Say we have been to Gulmarg a few days back, and we went to the hotel to have some food. And when we entered the hotel, we had some people serving us. Obviously, in Kashmir language it was like that. So if we consider them as functional units, so if we consider them as functional units, you will see, the system would happen like this. Pehla student andar jata, pehle aadmi ke paas jata, usdi hati mis baat, then बाकी पड़ोसने वाले ऐसे बैठे. Now he will go to the next. अब उसने उसको दिया मील 6 दिन क्या schedule. Then he will go to the third person. Are you getting what I'm trying to say? So what time it would have taken? It would have taken a day. We were just in 1 hour. So that time we would have gone in just eating. But we applied the concept of pipelining. The first student came and he was given the rice. But when he went to the next stage to have the concept to have meeting, but the first one who gave you rice, he was not captured unoccupied. So it was Davis rice. Now the pehla aadmi pahuncha teesre ke paas to have the cheese. The second one was having methi, and the first one was still unoccupied. Ab wo is par rice de raha tha. Do you get? So this means that the same concept applied. When we have the previous computers, the traditional computers, the whole processor was dedicated to just one instruction. To just one instruction. The fetch unit, the decode unit, the execution unit, even some other units. So when one instruction was used to fetch, the other units were still idle. They can't do anything, but still they can't do anything. When the first instruction was at the decoding stage, the fetch unit was staying idle. The execution stage was in staying idle. And when the first instruction executed, the other two units were staying idle. But as you know, we always are greedy in everything, and same is the case in technology. We are greedy in technology. And that's the concept here. Scientists thought, why not to ensure parallelism? When the first instruction is being fetched, it's okay. The decode unit and execute unit can't do anything. But when the first instruction is being decoded, the fetch unit, it can handle another instruction. It can handle another instruction. So the fetch unit was given another instruction. When the first unit came to when the first instruction was at the execution stage, the second unit, the decode unit was handling the second instruction, but at the same time there was a third instruction that was being handled by the first stage, the fetch stage. So this was the concept of pipelining. Now there arises a question, why use pipelining? It's very simple. To ensure parallelism, we have the concept of pipelining. And here we have the concept of pipelining. So you can see when the first instruction is being fetched, the other three units staying idle. When the first instruction is being decoded, the first instruction is being, the second instruction is being fetched, and so on. That means we are keeping each and every unit of the processor occupied each and every time. We are not letting the other units to stay idle. That's the concept of pipeline. Now I feel that it was enough as far as the concept of pipeline was concerned. Now comes the topic, that's the integer and Boolean execution using pipeline concept. First of all, I should have a very positive response. Have you got the concept of pipeline in layman's language? Also technically, now you have the right to pass smile. Now, talking of the present concept. Now, before getting into the details, some things are to be kept in mind. The book, in fact, it's a convention. You know there's a convention in physics when it comes to optics. There's a convention in chemistry when it comes to reactions. Same is the case in this architecture. We have the concept of fx. Whenever there is written fx, it means integer and Boolean instructions. So this should be kept in mind. So from now onwards, you will see the fx alphabet there. This means integer and Boolean instructions. Now next thing, जो हमारा आज का topic है, that's very easy. That's very easy. सिर्फ दो चीजें देखनी है. पहले देखिए जो आपने पाइपलाइन इस्तेमाल की, उसका लॉजिकल लेआउट क्या है. And the second stage is जो आपने पाइपलाइन इस्तेमाल की, वो कैसे इम्प्लीमेंट होगी. That means when it comes to DBMs, you know about DBMs. When we have to design a database, first of all we have to ensure the schema. Schema means what? What fields are needed? Simply touch पर लेफ्ट. हमें कौन-कौन से fields करने हैं? Choose. हमें ये नहीं करना पड़ता हमारे records क्या हैं. समझ आ रहा है? when we have to initialize a database, simply what we have to do, we have to write a schema. Same is the case here. When you have to use a pipeline, it's not necessary to have just 3 states: fetch stage, decode stage, execute stage. No, there can be a variety of states. We can have 3 states in some case. In floating pipelines, fixed point has got 4 states, but floating point has got 5 states. Then loads and stores have got 6 states. And obviously, I don't know, I'm a beginner in computers, but there may be even additional states. But the first thing you have to do when it comes to integer and Boolean execution, you have to say how many states I have. So, पहला important चीज यही है. So logical layout में हम बोलाएंगे it means कितने states हैं. The second concept is that आपने pipeline select की, आपने pipeline के states बताए. Now you have to say कि ये pipeline काम कैसे कर लेगी. So I feel I'm clear. Now we will discuss the 2 steps in detail. The first step is logical layout. Logical layout. जो मैंने अभी कहा कि you have to just to ensure to the reader that what states we have, how many states we have, simply their names. See guys, there's the fact that about 30 to 40% of the instructions in computers are integer and Boolean. ये स्टैटिस्टिक दी गई है जो 30 से 40% instructions कंप्यूटर में होती हैं, these are integer and Boolean. So that's why there was a need of enhancing a circuitry for them, a separate circuitry. That's why we have 2 types of processors in this regard, RISC and CISC. You know what's RISC, you know what CISC. RISC means reducing instruction set, and CISC means complex instruction sets. And from the name it specifies what does it mean. RISC means reduced. That means ये ज़्यादा instruction support नहीं कर देगा. Only a specified set. But CISC means complex. It can support every type of instruction. It can support every type of instruction. And एक और चीज़ जो this is the additional slide. अगर मैं चाहता तो skip भी कर सकता था. But this needs attention. RISC जो processors होते हैं, as they support only few instructions. That means they have been fabricated rather, to just handle those instructions where the operands reside in the register. जहाँ पर हमारे operands register में होंगे, RISC से डिजाइन किया गया है उनके लिए. So obviously when it comes to RISC processors, याद रखना है कि simply वहाँ पर register operations होंगे. So this should be kept in mind. But when it comes to CISC these processors, as they are very complex, they are immensely complex, so they can support everything. Register operations, even register to memory and vice versa. So we will just go one by one. First of all, we have the RISC pipeline. RISC processors, as I said, that they can go for the operations that happen between register to register. So simply the stage go on as we have been doing since BCA second year when we had a simple computer architecture. That means we have a stage known as the fetch stage. The instruction will be fetched, then we will decode the instruction, and yes, we have to access all of these operands. So they will be in registers. It's all this. हमारे को क्या चाहिए? Instruction में, for example, move x, bx. तो पहले आप instruction लोगे, fetch कर लोगे. In the next stage, you have to decode. अब तीसरे stage में क्या करना है? We will say कि यहाँ पर 4 चीजें, यहाँ पर 5 हैं. I know that students usually say passes like this. The second and the third mean the same. You will decode. But at the same time, you have to reference the operands, where they are staying. They are in registers. And ultimately, you will be asked to go for an execution. कोई operation तो करनी है. But when the operation will be completed, definitely, जो हमारा answer जाएगा, वो ही जाएगा into the register. That means write back. So this is fetch, decode, execution, and write back. Hope this is clear. I feel कि पहले instruction fetch होगी, then you have to decode, then you have to execute the instruction. Ultimately, आपका answer भी होगा register में ही वापस. क्यों? Because this is for, as I said, this is for register to register transfer. So this was RISC. But obviously, as I said, we are really in technology. Same the case here. RISC was given an enhancement. There was an enhancement in technology, and it's RISC. Well, experts said that we may involve one additional stage into this. That stage was termed as cache stage. Now, the question arises, which you don't seem to ask me, why the caching? Now, they said that we may even this is meant for register to register operations, but there can be an enhancement that it can also follow load and store. That means even operands that are in memory, they can be referenced now. So this means now this can go for both the things. Operations that involve operands residing in registers as well as operands that are in memory. So that is the additional. In fact, it's termed as a traditional mix pipeline. Hope this can be a lecture for you also. The next is the CISC pipeline. So before getting to the CISC, you should know that RISC had 2 important things. The basic traditional RISC has 4 stages, but the enhanced one has 5 stages. Talking of the CISC processors. Well, CISC, as I told you, it's very complex. It can support every type of instruction. It seems the case here, it can support both operations. when it comes to register as well as register to memory. Same is the case here. So there was a common sense. When we have to access memory, see, we have been through microprocessors. When we have to access memory, there can be two things. Either you have to load an operand in memory or you have to get an operand in memory. Is this clear? हमको जब memory access करनी है तो दो चीजें होंगी. या तो memory से operand लाना है या फिर memory में operand ले जाना है. When we have to get an operand from memory, this means load. When we have to place an operand in memory, this means store. But in both the cases, you have to locate the position of the memory. You have to locate the address of the operand in memory. So there is an additional stage that we call as the address generation stage. There will be fetching again, there will be decoding again, but now this time you have to generate the address of the operand. Whether you have to load, whether you have to store. In both the cases, you have to generate the address. But the next stage is that after you generate the access again, you have to perform the cache operation, ultimately there will be execution. And at the last stage, again, we write back, whether to memory or to registers. This is after the instruction and after the instruction set. But again, here came the concept of the greediness of technology. Same is the case here. But this time, there was a concept that people said, that experts said, we have a 6-stage CISC pipeline. We have a 6-stage CISC pipeline. They said, in fact, you can just go through your common sense and see. When you are using the execution stage, you are not using the cache stage. And when you are using the cache stage, you are not using the execution stage. ऐसे कहने का मतलब है कि जब आप memory में operand locate करते हैं, this is not execution. This is not execution. You are locating an operand in memory, or you have to get an operand from memory. So ये cache operation, but this is not execution. But when you have to execute or you have to multiply two operands, आपने पहले से ही operand ला के रखे हैं, आपने पहले से ही operand ला के रखे हैं, आप उस वक्त cache access नहीं कर रहे हैं. आप समझ रहे हो मेरी बात? Now we are getting the operands in the advance. Then we are going for the operation. That means, see, the problem with me this time is that I have to assume that you know something. I have to assume. But I can't go into the details, otherwise this presentation may long up to 6 p.m. So I am assuming you are getting me. See, when we have to locate the operands in memory, this is not execution. At that time, you are not executing anything. But when I load the operand from memory into the registers, after that I start execution. So at that time I'm executing, I'm not loading. Hope you get it. So they said execution and caching, these are performed in alternating, either this or this, not at the same time. So they said, let's make a common stage, either execution or caching. So when we will merge the states, we will have a traditional, an advanced CISC pipeline. Just containing 5 states. Basically, the difference lies in the fact that they have merged this state. They have merged this state. See, the question may arise that why this? Again, you can perform both type of operations from this. Register to register as well as register to memory. अगर आपको register to register करना है, that means fetch, decode, this address generation will get skipped. Because when register to register operation is performed, we don't need a memory reference. So this gets skipped. This part has got two sub-circuitry, execution circuitry and cache circuitry. But this time, what it will execute? Only execution circuitry. हम इसमें fetch, decode, then execution, then write back. So those steps बीच में skip हो गई. But problem नहीं है. Problem नहीं है. You know the concept of latency. यहाँ पर latency almost 0 होती है. तो obviously कोई problem नहीं है. But हाँ, जब आपको memory to operand, memory to register करनी है, at the same time, these all get executed, and it's common sense. It gets executed twice, and in technical language we say it gets recycled. It gets recycled. In the first, it will load an operand from cache, or it will store an operand into the registers. But then again, it gets recycled. It executes. So ये उस वक्त जब we have to go for memory to register instructions, उस वक्त ये 2 बार होता है. We say it gets recycled. Hope you get both the RISC and CISC processors. So this was the first step. जिसमें आपको एक बताना था कि हमारे पास कैसी पाइपलाइन है, इसमें क्या क्या स्टेज हैं. It was simple as simple can be. But the next, as I told you, there comes the next concept in everything. When first of all you need to get the material, then you need to implement it. Same as the case here. You have got either you have got the RISC pipeline or you have got the CISC pipeline. In RISC you have got 2 sub pipelines, and in CISC you have again got 2 sub pipelines. Now the next stage is that how you can implement it. आप कैसे इनसे